I'm going to record this to upload it in YouTube. So let me just go to the homework, and now let me just share here the screen. Let's just see the homework. With problems from the homework, okay? Share. Okay, you have A, B, C, and D, correct? Let's you solve these ones. Let me just go to these ones. Number 2. Let me just explain these ones, okay? I'm going to explain these ones in the other assignment anyway. Okay, so I have okay, so this is the first problem. This is our board, correct? So we're going to work this problem right here. Okay, now check this out. X and Y are mingled. You cannot set Y equals. It's impossible. You have ln here, you have Y squared here. So no way to put Y equals, okay? Y equals, impossible, correct? Impossible. Now, okay, but it's not impossible to get a derivative. Why? Because we assume Y is a function of X, correct? It's what we assume. Then this expression is all of it a function of X. Why? Because you have the ln of a function of X. That's a function of X. Then you take a function of X and you square it. So that's another function of X. So the only thing you have to see here is that this function is inside the function log, and this function is inside the square. So I'm going to use the chain rule, correct? Remember, chain rule. Chain rule. So if you have f of g of x, right? F of a function of x, then you want the derivative respect x of f of g of x, right? Is the derivative of the function you receive as you have it times the derivative of the function that is inside is what we are going to do, correct? So this is the only thing we are going to do. This is the calculus, okay? So this is an equation, so I'm going to take the derivative this side and this side. So I'm going to do, let me just v dx of x squared minus 3 ln y plus y squared equals, well, d dx, d dx, I'm going to close the parentheses, equals d dx of 10. 10, okay? Now, we know that the derivative of 10 is 0, so this is going to be equal 0. And now I have to take the derivative of these 3 portions right here. The derivative of the x squared is easy. That is 2x, so no problem. The derivative of 3 ln y is 3 times the derivative of ln y. Okay, we know that the derivative of the log is the reciprocal, 1 over y, times, as the chain rule says, the derivative of the y respect x. So we're going to write dy dx. Plus y squared. Again, I have to get the derivative of the square. Well, it's the derivative of the square, 2y, times the derivative of the function that is inside the square, dy dx. Okay? So the calculus is over, okay? The calculus is all over because you have this equation. Now you have dy dx. That is exactly what you want to know, the derivative of y respect x, right? So you need to find dy dx equals, right? Okay, this is a linear equation. Be careful with that. No matter what is 2x, this over y of this 2y, this is a function that is linear because dy dx are linear. So in the same way, as you solve, for instance, 2 minus 3x plus 2x equals 0. Okay, let me just put this one. Everybody remembers how to solve this equation?
Mm-hmm.
Yeah, everybody knows. So you combine these two. So you have 2, then you factor plus x parenthesis negative 3 plus 2 equals 0. Okay, is what you do, right? And then you move the 2, x negative 3 plus 2 equals 0. No, equals negative 2. And then you divide by the parentheses. So x equals negative 2 over negative 3 plus 2. I purposely not doing the operations because I'm going to do exactly the same right here. Check. Ready? Let's see if I can fit in this space. So I'm going to group these two. So I'm going to factor dy dx. So I have 2x minus dy dx, parentheses. You have negative 3 over y, you see? Okay, negative 3 over y. And here you have plus 2y. Plus 2y, parentheses, equals 0. Now, exactly as I did in my basic equations, I move the 2. I'm going to move the 2x. So I have, no, this is plus right here. dy dx, parentheses, negative 3y plus 2y equals negative 2x, correct? And what is the last step? Well, the last step was divide by the parentheses, so I have to divide by the parentheses, so dy dx equals negative 2x over negative 3 over y plus 2y. And that is my answer, okay? So this implicit differentiation was something we did before in the semester, last semester. The only situation now is, well, yeah, there is a log involved, the ln function, but everything else is the same thing we did during the first semester. So, a ver, first part, this one. Let me just isolate this part. Any problem with this one? This cannot be solved for y. You assume that the y is a function of x, and then you're going to use the chain rule. What is the chain rule? If you have a function inside another function, the derivative is the derivative of the outer function times the derivative of the inner function. That's the chain rule. Okay. Now I'm going to use that in the problem I have. I am assuming the y is a function of x, so I have x squared 3 times ln and inside a function plus the square and inside a function. So I can use this. Then I take the derivative both sides. The derivative of the constant is 0. Then I get the derivative of x squared, 2x, that's easy. Then the derivative of this is the reciprocal times the derivative of the function is inside the log, plus derivative of the square, 2y, times the derivative of the y itself. Okay, once I have this one, I have a linear equation. Why? Because this equation right here is linear here and linear here, exactly as I have here. Linear here and linear here. And these x, y's, and everything is right here are numbers, pretty much as the 2 and the 3 and the 2, correct? Okay, so the only I have to do is now solve a linear equation. So I group the like terms, yeah. I move the independent term to the other side, and then I divide by the things in parentheses. Well, I exactly do the same. I group these together. I factor dy dx, that is what I want to solve. This is 3 over y, negative. This is plus 2y. I group these parentheses here. Then I move this to the other side, and then I divide by the parentheses, and I get the answer. Nothing new. Same thing always. Okay? Any question in this point? Pretty easy?
So,
Okay.
Ramirez,
Yep.
okay, so at the beginning you said you can't solve for
Y.
because there's two variables?
No, because you have this one and you have a quadratic.
Because
So
the y
it's
is attached
impossible
to
to
the natural
break this
log.
one, right? Remember what you did in the basic algebra for that. Yeah. Let me just put this one right here. Let me just take this little ball right here now. Right here. Yeah. Suppose I give you this one. 2x minus xy equals 3. And I ask you, what is y equals? What you do?
Factor out the x.
You move this x, correct? So you have negative xy equals 3 minus 2x. And then what? Yeah? You divide by the negative x. So 3 minus 2x over negative x. So you were able to put this one as a function of x, correct? Now let me just put this one in the worst way. 2xy minus x sine of y equals 3. Now the y is inside the sine and the y is with the x. So this is impossible to set in y equals. There is no way to move it, right? There is no way to solve. Okay? So the situation, very simple. Even if this is impossible to break, you can take the derivative because this is a function of x, and if y is a function of x, you have a product. And here you have an x times the sine of a function of x. So you have a product, and here a compound function. So you can use the product rule and the chain rule, and then you break the problem to solve dy dx, correct? Dy dx, to find dy dx. So is the advantage to use the chain rule, correct? So you don't have to solve for y, okay? Bueno, let's do another problem here from the assignment. Now I'm going to show you how to solve derivatives that are difficult functions there. Okay, so we have to go back to the assignment with the C. Okay, so I have to go, let me see, this one. So we have to go back to this assignment, the one we began yesterday. We did these ones yesterday. Now we are going to begin these ones that are difficult problems without the log, okay? You see, these derivatives are going to be very difficult, and these more and more and more and more, you see? We are going to use the logs to break them, but I'm going to begin with an easy example, this one, okay? So I'm going to have y equals x plus 2 times x plus 4, correct? Now, let me just go back to the board. Ahí está. This is the problem we are going to solve. I need y prime, correct? This as well. You can tell me, this is easy, mister, because you can get the product or you can multiply and get the derivative of the quadratic. That's correct. You can do that. But I'm going to show you a method that possibly here is going to be annoying, but in the next problems is going to be very useful. So the first step, step number 1, right? Step number 1 is take the log both sides. ln y equals, you take the ln of the product, so you have ln of x plus 2 plus ln of x plus 4. Remember, I'm using these properties. Remember the properties yesterday we used. Okay, now, second step, step number 2, you take the derivative both sides. Now, this is going to be the calculus, derivative both sides. So I'm going to take derivative respect x of ln y equals derivative respect x of ln y of x, ln of x plus 2 plus ln of x plus 4, right? That's step number 2. Well, now I have to remember, I'm going to make here a window. Derivative respect x of ln u. What is the derivative? Okay, it's 1 over u times u prime, correct? That's the formula I'm using. This is the formula I'm going to use here. Yep.
¿En cuál problema estamos?
En el C, aquí mira. En el assignment C52, the one we began yesterday, is the page number 3, is the assignment C.
Okay.
¿Ya lo viste? C.0, C5.002. Okay. Bueno, let me just go back to the board. Okay, there it is. So this is the formula we're going to be using, okay? Okay, now, using this formula here, well, I have 1 over y times y prime, okay? Here, I'm going to get the derivative of this and the derivative of this. Now, using the same formula, the derivative of this is 1 over x plus 2, correct? Times the derivative of x plus 2, but that's a 1, plus the derivative of this, 1 over x plus 4, here is the formula, times the derivative of x plus 4, 1. So, okay, the derivative is over. Now the calculus is over. Now, what I have to do? I have to solve for y prime because I need y prime, you see? Okay. Y prime is y times 1 over x plus 2 plus 1 over x plus 4, right? Now, the only thing I have to do is, who's y? Well, y is right here at the top, you see? Y is right here at the top. So what I'm going to do is x plus 2 times x plus 4, parentheses, 1 over x plus 2 plus 1 over x plus 4, right? So that's the step. So step 1, step 2, and this is step 3. 1, 2, 3. Obviously, we can, with the practice, we can skip some of these portions, but the steps are the same, correct? So, reviewing this again, you have a function that is y equals, okay, is products, quotients, something like that. You want to use this formula to ease your work. What you're going to do is you are going to take the log both sides, log of this portion and log of this portion. So use the rules of the logs. Once you have this broken in pieces, you take the derivative of every side. Derivative of this, we use this formula, is right here. Derivative of this is derivative of this plus the derivative of this. We use the same formula. And then we get these two expressions. We finish with the derivatives. The derivatives are simple. Okay? Then you need y prime, and you have this term right here. Well, we multiply everything by y, so I have y times these two expressions. But the problem is, who's y? Well, y is right here. It's the first thing I got. So I just write it, and this is my answer. Possibly you say, oh, it's easier to multiply and get the derivative term by term. Yes, it is. But
Wait, so sorry, Marius. Y prime is going to be equal to the last part, starting with x plus 2 times x plus 4 times the derivative.
correct.
Okay.
Yes, it's just this one. It's because you get this one, you see, right here. So 1 over y times y prime. So I multiply everything times y, and I get my final answer. If we do this algebra, it's exactly the same answer. That if we multiply and get the derivative of the quadratic. Obviously, here looks very annoying because, well, it's too much, mister. But in the problems that are complex, this is going to be the same size. This is the advantage. Okay? Okay, let me just move to the next problem. So the problem we're going to be solving is this one. Now the product of 3, you see? B. So I'm going to have y equals x plus 1 times x plus 2 times x plus 4. And I want y prime equals. So what is the derivative of this expression? Okay, so let me just break this. Right? Okay, this is what we have to solve. Okie dokie, no problem. So what I'm going to use is the derivative of the log d dx of ln u. So 1 over u times u prime, correct? And the properties of the logs that you know already. So I'm going to take the log both sides. So I'm going to have the log. So I'm going to use ln y equals, the ln of a product is the addition of the log. So it's ln x plus 1 plus ln x plus 2 plus ln of x plus 3. There is. I break the problem in 3 little portions, okay? 3 additions. Okay, now I'm going to take the derivative both sides. This is step 1. Remember, this is step number 1.
¿No sería x plus 4?
Así x plus 4. Yeah, thank you. I copied in the wrong way. Okay, now I'm going to take the derivative both sides. So I'm going to take derivative respect x of ln y equals derivative respect x of ln x plus 1, ln x plus 2, plus ln x plus 4. There is. Okay. Now, the calculus. This, using this formula, 1 over y, y prime. The derivative of this plus the derivative of this plus the derivative of this, using the same formula, is going to be 1 over x plus 1 times 1, because the derivative of this is 1, plus 1 over x plus 2 times 1, plus 1 over x plus 4 times 1. The calculus is over. Okay? Now, what I have to do now, this is step 2. Now, step 3. The step 3 is, okay, I have to multiply times y to get my answer. But the y is already this one, so I'm going to write it. Y prime equals x plus 1 times x plus 2 times x plus 4 times the expression in parentheses. Yes, it's kind of writing, but it's not difficult writing. So what we are going to do is very simple. With the time, we are going to skip this step. And I'm going to do this, mentally the derivative this, and the answer this. And if you want to go faster, once you get the derivative, you are going to see that always you multiply times the original expression. So you're going to put y prime, the expression, parentheses, and then the derivative of every portion. So this is an advantage because in complex problems, it's always the same. Okay? So, any problem with the 1, 2, 3 steps? No? It's a cat, Aribon? Is your dog? What is? Ah, it's your dog.
Yeah, es un perro.
Nomás está una oreja, se ve una oreja nada más. That's a big dog.
Peppers.
Ah, pues sí. ¿Un schnauzer?
Sí.
Está bien. Okay. Otro problema, more complex now. Is going to be problem C. Now, you can see here that this is a product of a square root. Yeah, the derivative of the square root is more complex. And here in the next problem, you're going to see power, so it's going to be more complex. Here you have quotient that is more complex. And you're going to see that in these 3 cases, the amount you have to write is the same. So let me just put right here, y equals 2x plus 1 times 4x squared, the square root of x minus 9. Okay, so right here, there is. So this is the expression I want to work. So I want to find y prime. Yep. So remember, I'm going to do my step 1. Step 1, I apply the log. So ln y equals ln 2x plus 1, right? Plus this one is a product, so you can do ln 4 plus 2 ln x. Why? Because the power puts the exponent at the front, you know that. And this one is going to be 1/2 because this is the square root. The square root is power 1/2. So you have 1/2 ln x minus 9. Yeah, it's long, but this is a collection of easy problems to solve. So you don't have to scare about this. This is compact, but it's difficult to work. This is a collection, possibly long, but of easy problems to get the derivative. You see, Problem number 2. Oh, really, step number 2. The step number 2 is the derivative. Now give me the derivative. This is 1 over y prime. It's always the same. You are going to see that. Derivative of this, okay, the reciprocal, 2x plus 1 times the derivative of this. Okay, the derivative of this is 2. Derivative of the constant 0. This is twice, and the derivative of this, 1 over x times 1, because the derivative of the x is 1, plus 1/2. Derivative of this, okay, reciprocal of that expression, times the derivative of the x1. It's over. The derivative is over. The calculus is over. My answer, y prime, that's step number 3. Yep, is, okay, why is all this horrible thing? So you have 2x plus 1 times 4x squared, square root of x minus 9, parentheses, and then you have to copy down this one. 2x plus 1 plus 2 over x plus 1/2 times 1 over x minus 9. You see? It's the same 3 steps. No more. Same 3 steps. And this problem is more complex than the previous 2 I solved, you see? Correct? Same 3 steps.
Ramirez.
Mm-hmm.
So is that all we have to do? Like we don't have to, like that would be our answer?
Distribute here? No, this is correct. You don't have to try to distribute and simplify. Check this. There is nothing. This is the derivative. This is the derivative. Okay? Don't try to mix these terms. Okay? Don't try. Because you are going to lose this simplicity. This is compressed. Same as this. This is the best compression you can have. If you distribute, you are going to get a monster. No, you didn't receive a monster. You received this compact. Okay? So don't try to do more. Okay? Well, one more. Now the problem is going to be y equals x squared plus 1 times x squared plus 2 times x squared plus 3 cube. Okay? Now, this one is more difficult because, yeah, multiply these two, no problem, but expand and multiply, you're going to have a big monster. So, okay, no problem. I'm going to use the logs. So, ln y equals the log of this plus the log of this plus the log of this. Okay, ln x squared plus 1 plus ln x squared plus 2. This is a power, so this is going to be 3 times the ln of x squared plus 3. Yep. Now, calculus. If you want to save the step 3, you can do this one. Step 2, calculus, y prime equals, and then you put the y. Okay, x squared plus 1 times x squared plus 2 times x squared plus 3. You know, always is the same. Parentheses, derivative of this. Okay, 1 over x squared plus 1. And at the top, the derivative of the bottom, 2x. Plus x squared plus 2, the derivative of this, 2x. Plus 3 times derivative of this log is x squared plus 3, 2x. And that's my answer. You see? I don't have to do more. Even I skip really step 2 and I put step 3 already. Right? So with the practice, you are going to be able, from this expression, you get the derivatives here in the parentheses and you multiply times the original expression. Always is the same. So you can skip the last step you want. Correct? And don't do more. This is good enough, okay? This is compressed. This is the optimal expression. If you distribute, you're going to get a monster. That's not optimal expression. This is the optimal expression. Okay? Now, let's do a quotient. You're going to see now. So, y equals x plus 1 cube over 3x plus 1 square. Now you remember the quotient rule for derivatives is horrible. If you try to do this with the quotient rule and you have a product at the top, you're going to get a horrible expression. So logs are here to save you, okay? So step number 1, take the log both sides. ln y equals, and here your proficiency with the logs is important. You should be able to do this in one step. So I have the log of this, 3 times the log of this, minus 2 times the log of this. I have to use the rules mentally. ln x plus 3 ln x plus 1, right? Yep. Minus 2 ln 3x plus 1, correct? So the big problem now is 3 little ones, easy to work, okay? Derivative, step 3, y prime equals, these derivatives are going to be multiplied times this one, so I'm going to write it, x plus 1 cube over 3x plus 1 square, parentheses. Now, derivatives of these 3 little things. Derivative of this one, 1 over x. Derivative of this one, x plus 1 reciprocal, and the 3. Derivative of this one, 2 times 3x plus 1. And the 3 is the derivative of this, so I put it over there. Ahí está mi answer. So if you try to do this when using the quotient rule, you're going to spend half an hour. You're going to get a horrible expression, and possibly you're going to make a mistake because the more operations, the more mistakes. With the logs, you see, you broke in 3 parts, and usually you get the answer. This is a good answer, okay? Everybody catch the idea? No questions? A ver. From the next page. Next page, this is the problems I solve. Would you like to try this by your own before I do something? Right?
Which problem is it?
F in page number, that's page 4. In page 4 in the assignment C, right? You have the problem F.
Ramirez, the mouse is on the problem is okay, that's else.
You don't see?
Yeah, I didn't see it before, but I got it now.
Okay, here is. Okay, that's the problem. This problem F in page 4. Just try by your own. And you're going to see that it's easy. Easy, really. Of course, you have to be proficient with the logs. That's my point. Wow, we have just 1, 2, 3, 4, 5, 6, 7. Nobody else. Okay.
So we get 100?
Okay, let me see. What is the log of this? Is ln y equals ln of this, ln x, this ln twice ln x squared plus 1 minus the ln of this 1/2 ln x plus 1. So my expectation is from here you write this directly in one step because you know the rules of logs. Then y prime is, you know that whatever comes from here is going to be multiplied times the original. So you put x squared plus 1 square over the square root of x plus 1. So you have to write again, and then you're going to put the derivatives. Derivative of the first one, easy, 1 over x. Derivative of this one, 2 times x squared plus 1, always the reciprocal, then the derivative, 2x. Minus 1/2, reciprocal x plus 1. 1 is the derivative of x plus 1. That's my answer. Believe me, if you try this by the regular way, this is going to be a pain. This is easy. So logs are here to make your lives easy, not miserable, okay?
Mr. Ramirez, I got it. Are you proud?
Always proud of you. Ok, a ver, otra más. Let me see qué pasa aquí. ¿Por qué no puedo ver la pantalla? A ver. Okay, there is. Now you see? You see the screen now? I want you to do problem G, this one. Okay. Okay. There is. Resume share. Stop share. There is. This is the function. Okay. Your expression now is long, but it's a collection of easy problems. Okay. I rely on your knowledge of the formulas. You must know the derivatives. You must know the logs. If you know them, if they are in your brain, then you're going to be this efficient, okay? If you fail, what is the derivative of the cosine, or what is the derivative of the sine? That's a problem.
So,
okay, what is the problem, Mary?
So the last two functions that are under the in the denominator, both of them are you're subtracting both of them?
Minus, correct. Yes. Everything in the denominator goes with minus. Everything in the numerator goes with plus. Yeah. If you have 3, you are going to have 3 minuses. Okay. No problem, Yvonne? Everything fine? Good. Andrea, you're still there? Así está, mira, Andrea. Ah. Okay, good. And Mia is still swimming? No, you are here. No problem, Oscarito? Okay, good. Well, you think you need more examples or these are good enough?
Está bien. Dice Olis Chris.
Okay, very good. So, if you want to reinforce this one, you have more practice here. Let me just, in the same assignment, right? Share screen. This one again. In this one, you have more problems, these ones. The integrals are going to be for tomorrow, okay? So, this is the easy stuff. The integrals are always a little bit more complex, but derivatives are kind of easy. So you can practice this if you want. And of course, you have your little homework. Now you learn how to do these ones, right? Here you have the same kind of problems we did now. You see, same kind. And then the integrals. So you can go problems A through D. And you think you need extra help here in these ones? You want an extra more?
For which ones?
The ones that are implicit differentiation.
Mm,
Déjame ver aquí. Because
Is
I
it-
didn't put implicit differentiation in the other assignment. Okay, let me just go back here. For instance, we solved this one, problem A in page 2. We can solve any of the next ones. I don't know. What do you think?
mm,
C, D, A, B, B, C, or D? Which one? Well, let me just try D. Just to close this one. D. D is y squared plus ln xy equals 2. So here is my board. This is the expression. Y squared equals ln xy equals 2. Correct? So I want y prime or dy dx. Remember, in implicit differentiation, dy dx is the one we use. Y prime usually is for everything else, but it's the way the textbooks work. Okay, no problem. You cannot solve this for y because the y is inside the log, the y is squared, so impossible. But you assume that the y is a function of x. So here you have a function of x squared. You have ln of x times a function of x. So all this is a function of x. So everything is going to be a function of x, correct? So what I have to do is take derivative both sides. Derivative respect x of y squared plus ln xy equals derivative of the 2 is 0. So I don't write it. Now I have to do the calculus. Derivative of the power 2y times the derivative of the y. Okay, dy dx. Derivative of this thing. Okay, this is going to be 1 over x y, the reciprocal of this, times. Now, this is a product. The product of x times a function of x. So I have to use the product rule, remember. F prime g plus f g prime. This is the rule, correct? So I take the derivative of the x is 1 times the y, y, plus the x times the derivative of the y. Well, I don't know it. It's just dy dx equals 0. Okay, now remember that this resembles a problem like this. 2x, oh, let me just another variable. 2u plus, suppose 1 over, I don't know, 5 u plus, let me just put another number 3. No, this is, I'm supposed to put here on 2, and this is a u equals 0. Suppose in your Algebra 1 class you get this problem. How do you solve it? Okay. I break the parentheses, so I have 2u plus 2 over 5 plus 3 over 5u. Okay, equals 0. Then I group these two. Okay, I'm going to group them, parentheses 2 plus 3 over 5 times u plus 2 over 5 equals 0. What do you do with the 2 over 5? Okay, I move it to the side and then I divide by the parentheses. So u is 2 over 5 divided by 2 plus 3 over 5. Algebra 1. Well, I'm going to do exactly the same with these parentheses, you see? So I'm going to do my algebra. So I'm going to break my parentheses. So this is 2y dy dx, dy dx, plus x over y, paréntesis y plus, bueno, vamos a ponerlo así. This is y over x, y, plus x over x, y, dy dx equals 0. So I distribute this xy with these two, right? Well, here I can simplify the x's, here I can simplify the y's. So I have 2y dy dx plus 1 over y plus, no, 1 over x here, 1 over x, 1 over y, dy dx equals 0. Then I group these two again, as I did here in the other problem. So this is dy dx, parentheses 2y plus 1 over y plus 1 over x equals 0. Okay, I'm in this step right here. Now, what was the solution in this case? Well, you move this to the other side. Here is a negative, I forgot. So is this here and then divide by the parentheses. So dy dx equals negative 1 over x, parentheses, 2y plus 1 over y. And this is my answer. Okay? The algebra for this, possibly you can try to simplify this complex fraction, but this is good enough. Okay? So to solve these ones, you need algebra 1 again. Okay? Algebra 1 is the same kind of problems. Don't be scared because this looks scary. Okay? These are the same kids, just here. They are dressed for Halloween. These are the regular kids. So don't be scared of the kids dressed like Halloween. They are kids. Same as you handle here, you handle them here. Okay? Okay, was a pleasure to work with you. No questions? So continue with this one. We continue tomorrow at 10. Oh, yes, at 10. It's better 10 or 11? What is better, 10 or 11?
No matter.
Yeah, I don't know.
No, no importa.
I was like, I
That's
want to
fine,
sleep
okay.
in.
Yeah.
Then,
I don't know,
11.
girls. If you take too
11
much
is
time for the
fine.
makeup and the hair and all those things to look beautiful.
Obviamente no, Ramirez.
Remember, I'm going to post this in YouTube, okay?
Claro que sí.
For the YouTube
Te haces el
channel for
famoso.
somebody else, okay?
Wait,
Bueno,
so what,
Voy a dar un diamond play cosa.
take care. See
What
you
time?
tomorrow. The
Wait,
code
I know, because-
for the Zoom is the same, okay? It's the same code.
I
¿A
know,
qué
but what
horas,
time
Diana?
It's the same
Five.
code. Take care. See you tomorrow.
Ramirez.
Ramirez, wait.
What
What
happened?
time?
Ramirez.
Are
A
you
las 11 o a
copying?
las 10. No.
At 10.
Okay. Adiós.
Okay, bye.
Okay.
Bye.
You are copying the green part, Maria?
Yes, I already did.
Okay.
Thank you.
I know, sorry. It was too fast.
No, I got it. I understood, surprisingly.
So, ready, Oscaro?
Sí.
Mari? Yep.
Mm.
Jasmine?
Mr. Ramirez,
Yep.
is the homework supposed to be missing a page?
No, I'm going to upload the PDFs instead of words. I'm going to
You know-
upload it. I'm going to send you a remind informing you that I upload those in Classroom, in Google Classroom, okay?
I just realized I had my thing on mute the whole time and I didn't know.
Okay, well, everybody's learning now, yeah? We are really ahead and other teachers and other classes. We're having this already. And we have the YouTube channel to repeat the things. Many teachers are off completely. So don't worry, everybody's learning. Okay, see you tomorrow. I'm going to post those PDFs in a few minutes, okay?
All right.
Okay.
Google
Yeah.
Classroom. Bye.
Bye.
Bye.